Well, guys, we're hitting a mega review night tonight. We're focusing on a lot of radicals, and to be specific, we're going to add, subtract, multiply, divide, solve radical equations, and fractional exponent equations. So buckle up, it's going to be a long ride, take good notes, and it'll prove to pay off. Alright, well, let's get this show started. Our first piece of radicals is going to be adding and subtracting radicals. Alright, so let's make some bullet points and talk about what we need. We need like radicals before we can add or subtract. And two, we want to add or subtract only outside the radical. Alright, we're not going to touch inside the radical. So let's run through some examples. Number 1. Radical 2 minus 3 radical 2. Alright, so in front of every radical, if you don't see a number sitting here, of course there's that nice imaginary 1. And because these radicals are the same, they both say radical 2, I am just going to subtract the outsides. So 1 minus 3 is negative 2, and you're going to keep the radical 2. And that's our final answer. We're only adding or subtracting the terms outside. Let's try another example. Square root of 18x cubed minus the 5 square root of 2x cubed. Now, you can't just add or subtract these radicals because notice, the junk under the radical is not the same. So my job is to make it the same if possible. So we've got to break these down. So let's start with 18. How would we break down 18? Remember, you want a perfect square and a non-perfect square. I'm thinking 9 times 2. Now, I can break x cubed down as well. Because it's a perfect square, I need a square and then a non-square. So that totals 3. I've got 2 here and 1 here for a total of 3. I'm going to do the same thing with this pair over here. Notice I can't break 2 down, so I'm going to leave it, but I can break the x cubed down as x squared and just x. Now as I go through, I know the square root of 9 is the number 3. I know the square and square root on the x is going to cancel, and I'm left with radical 2x. Same thing over here. I know the square and square root is going to cancel, so I've got a minus 5x. That'll come out. And then I'm left with the 2x under the radical. Now, ask yourself one last time, do you have like terms? Is the junk under the radical the exact same? If your answer is yes, we can subtract. So 3x minus 5x makes negative 2x, radical 2x. And that's my final answer right there. So I'm just adding or subtracting the junk in front of the radical once my radicals are the same. Let's try another example. Example 3. The cubed root of 8x minus the cubed root of 16x plus the cubed root of 27x. Now, I tried to mess with you a little bit. Notice we have cubed roots this time instead of square roots. Again, right off the bat, they're not the same, so you can't just go around adding. So I've got to break them down. But now this time, I want perfect cubes. Well, 8 is special because 8 is a perfect cube. Can you think of a number 3 times that makes 8? Hopefully you've got 2 times 2 times 2. So 8's a perfect cube. And since this exponent's a 1 on the x, it can't get simplified. Minus, is 16 a perfect cube? Are there 3 numbers you can multiply to get exactly 16? Well, 2 times 2 times 2 is 8, and 3 times 3 is 9 times 3 is 27, so that's a no. So I've got to break it down to a perfect cube and a non-perfect cubed. So let's go through those perfect cubes again. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Those are my only perfect cubes. Can one of these go into 16? Absolutely. That would be 8 and 2. And then I still have that cubed root of x. And lastly, I'll put my third one here. 27, notice it is a perfect cube. So I'm going to leave that as the cubed root of 27. And the cubed root of x. Alright, so as I clean these up, cubed root of 8 is perfect. That was the number 2. Cubed root of x. Minus this cubed root of 8, again, is 2. And I'm left with the cubed root of 2x. Plus the cubed root of 27 is 3. And I have the cubed root of x. Now, ask yourself, do you have any like terms? Is any junk under the radical the same? Well, I would say this term and this term are the same. They both have a cubed root of x. So that's a total of 5 cubed root of x minus 2 cubed root of 2x. And again, I can't go any further. That will be my final answer. Alright, let's dive into some multiplying radicals. So here's our rules. We're going to multiply inside the radical and outside the radical. And then lastly, we'll just simplify. So example 1. 3 radical 5 times the quantity 2 radical 8 minus radical 10. So my first instinct is not to break these down. It's just to say, okay, use some common sense. What would you do with you junk outside of parentheses? Hopefully you're saying you would FOIL. And just remember, you're going to do the outsides and the insides. So start outside. Outside, I'm going to get 6. Inside, I'm going to get radical 40. Then you have that minus sign. And again, the outsides. Outside, I'm going to get 3. Inside, I'm going to get radical 50. Okay, so that key is outsides and then insides. Now again, I can't add these together because they're not the same radical, but I can break them down, and we always want to make sure we simplify. So what goes into 40? And remember, you want a perfect square and a non-perfect square. I'm thinking 4 times 10. And what goes into 50? If you ever get big numbers, start thinking of money, like 25s or quarters. I would say 25 times 2. So I know the square root of 4 is the number 2. Now what the heck would I do with these two numbers out here? Alright, they're just sitting next to each other. What operation do you do when terms are sitting next to each other? You've guessed it, just multiply outside. 12 radical 10. Again, this will turn into the number 5. Alright, I don't see a plus sign here, they're just sitting next to each other. So that's going to get me a times 15 radical 2. Now, is it possible to add these together? No. So that's just your final answer, and that's okay. You're going to get things that look like that you just can't add together. Alright, let's keep going and try another one here. We'll make it a little more exciting. So we've got negative 3 times the square root of negative 2x squared y cubed times 4x square root of 6xy to the negative second. Alright, so just like we said, we're going to multiply outsides and then insides. So outside it looks like negative 12x. Inside, negative 2 and 6 make negative 12. X cubed, and y, when you multiply again, add the exponents, I'm just going to get y to the first. Now, you're not done until you simplify. So let's break it down. I'm going to leave my outside alone. I'm thinking 4 and 3 make 12, and a negative 1 to get my negative 12. I'm going to go with an x squared and a plain old x, and then just a plain old y. Hopefully you agree with that. Again, 4 times 3 gets me the 12, and the negative gives me the negative 12. The cubed, I'm going to go with an x squared and an x, and then a plain old y. I know the square root of 4 is a 2. The square root of a negative is an I. The square root of x squared is just x. So outside, I'm going to say that's negative, that 12 and 2 make negative 24. I've got an I for my imaginary number. I've got an x and another x, which gets me x squared. And then inside that square root, I'm left with a 3, an x, and a y. Okie dokie, let's try another multiplying problem. Here's a pretty common multiple choice type question. They'll give you the quantity 4 radical 2 minus 3 radical 5, and they say square that quantity. So again, when you want to square something and there's a plus or minus sign in there, you've got to write it out twice and FOIL. So 4 radical 2 minus 3 radical 5. And I'm writing the same thing out. I'm just squaring it. Alright, so why don't you pause it, try it on your own, and see if we get the same thing. Remember, multiply outsides and insides. So you can take a quick peek at my first line, see if you agree with that. If you do, check out what I do next. So I said my radical 4 is a 2, my radical 25 is a 5, that gives me a 45 and a 32. Put my like terms together here, and I'm left with 87 minus 24 radical 10. Now, my dividing radicals always scare some people, and it's really not that bad. It's similar to multiplying. Just divide this time the outsides and the insides. Do not leave a radical in the denominator. And then, of course, make sure you simplify. So let's try some examples. We'll start real nice and easy. The square root of 14x cubed y divided by radical 2x. Now, some people, and let me show you two examples. Some people are going to want to multiply by that radical to clean up the top. I don't actually suggest doing that. Because there's no plus or minus signs, just simply divide. All right, divide inside and divide outside. Well, outside, there's really nothing to divide. So now divide inside. 14 divided by 2 is just 7. X cubed divided by x is x squared. And y. Look how simple that is now. Now, just clean this guy up. Can you break down radical 7? No. X squared and simply y. And then lastly, I can cancel these. And my answer is just x radical 7y. Do you see how nice that was? And again, I didn't have to do this because I don't have a conjugate. I don't have that plus or minus sign. All right, a very similar problem. The square root of 200 x to the 10th y to the 5th divided by 4 square root of 10xy squared. All right, so let's start outsides and insides. Outside, I have a 1 divided by 4. Well, all I'm going to do is leave it. I can't really simplify that at all. Now, divide insides. 200 divided by 10 is 20. And I'm going to put it over here, actually, so I've got radical 20. X to the 10th divided by x is going to leave me with x to the 9th. And y to the 5th over y squared. Remember, when I'm dividing, I'm subtracting. I'm getting y cubed. All right, so just watch how we clean this up. Notice all this junk, all this junk is on top. The only thing on the bottom is the 4. So I'm going to say 1/4. I'm going to break up my 20 in 4 by 5. I'm going to break up my x to the 9th as x squared, x squared, x squared, x squared. So that's 2, 4, 6, 8. I need another x, and I'm going to put my y's underneath. Y squared and just y. And that should add up to 3. And then lastly, we'll just simplify this. So I've got 1/4. That turns into a 2. That's going to be a 1, 2, 3, 4 x's, so x to the 4th, and a y. And then it looks like I'm left with a radical. I've got a 5, an x, and a y left over. And lastly, I can clean this up. This is really 2 over 1. And so on top, I get a 2. On the bottom, I get a 4. 2/4 reduced to 1/2. X to the 4th y, radical 5xy. All right, this one's just a tad different. I've got the cubed root of x to the 5th y divided by the cubed root of negative 27. Now notice, if I divide the insides, I'm not getting anything fancy. I don't even have a number up here to divide by. But this is special because 27, remember, is a perfect cube. And again, I can review why. 3 times 3 times 3 is 27. Now, the main question that we all get fooled on, is this 27, is this negative under the radical, going to give us an imaginary number or not? Well, here's the deal. If you can come up with a negative 27 by using 3 numbers, then it's not imaginary. If you can't, then it is imaginary. Well, we already know it's not positive 3, because 3 times 3 times 3 is positive 27. But how about negative 3? What's negative 3 times negative 3 times negative 3? Well, these two negatives make a positive, and this negative turns it back to a negative. So it is possible to take the cubed root of a negative 27. That just turns into the number negative 3. Now, let me go off on a side note. Is it possible for me to take the square root of, the square root of negative 4? Well, all you have to do is say to yourself, is there two numbers you can multiply to get negative 4? Well, what happens if you do positive 2 and positive 2? Does that equal negative 4? No. What if you do negative 2 times negative 2? Does that equal negative 4? No. So since it's not possible, this answer would be 2i. If it's not possible, it turns into an I. Back to this problem, all I have to do is break down that top then. So I'm breaking down the cube root of x to the 5th, so I'm going x cubed and x squared gives me a total of 5. And then the cubed root of y. So that's going to zap out, and I'm going to get an x cubed root of x squared y all over -3. So on this last dividing piece, I just want to stress that if you can't divide and it doesn't turn out nicely, that you could use rationalizing in the denominator. So in this case, since 4 divided by 3 doesn't turn out very nice, it's probably easier for me to multiply instead of just dividing. All right, so again, if you can divide, I stress dividing, and if you can't, then just multiply by that denominator. So now I'll just apply my multiplying rules. When I multiply insides and outsides together, so on top, 4 times 3 is 12, x to the 4th y. And on the bottom, any radical times itself just cancels. If you don't believe me again, you could say this is really 9x squared, and then I think you'll see that we should just turn out with a 3x. Okay, so now I can clean up. Again, on the bottom, I just get 3x. 9 is a perfect square because of 3, x squared because of x. And one more time to point out, any radical times itself is just the junk under the radical. On top, I can break that down to a radical 4, a radical 3, an x squared, and a y. And again, you'll notice some nice stuff. That becomes a 2, that becomes an x, and that makes x squared. And now I'll get a radical 3y all over 3x. So again, lastly, I can reduce one of these x's here. So I've got 2/3 as my fraction. I've got an x and a radical 3y. Alright, so again, it's your choice. A lot of times, if you can divide, it's easier, and if not, then just multiply and rationalize the denominator. Alright, we're going to switch gears and talk about radical equations. Now, equations obviously have an equal sign based off the word equation, and here are the steps we need to follow. Just like if it was absolute value, you need to isolate the radical. That's been our key theme here. Isolate the radical first. Square each side, solve, and of course, the most important one of all, make sure you check. Number 1, x equals radical 30 minus 2x, and then plus 3. So again, my first step, you can't just go around squaring, you have to isolate the radical. I need to get this by itself. So if I see a plus 3, hopefully your gut says subtract 3 over. So I've got x minus 3 equals the square root of 30 minus 2x. Alright, step 2 is one side radical is isolated. I'm going to wrap each side up in parentheses and square it to kill the radical. Alright, so that just kills that out. So my right-hand side is just 30 minus 2x. Now, my left-hand side is going to take some work. If I want to square a function, I have to write it down twice and actually FOIL it out. So I'm going to get x squared minus 3x and minus 3x make minus 6x plus 9 equal 30 minus 2x. Gather your x's on one side. Actually, gather everybody on one side and set it equal to 0. I'm getting x squared. I'm going to add 2x. So that's a minus 4x. Subtract 30. So that gives me a minus 21 equals 0. Alright, some quick factoring. Remember, it's MAM, multiply, add, multiply. Multiplying to x squared is just x times x. Multiplying to 21, I'm guessing 7 and 3. And can I make a negative 4 somehow? Well, if that 7's negative and that 3 is positive, I believe that gets me a negative 4. And I'll quickly tee it up and solve. X minus 7 equals 0, therefore x equals 7. X plus 3 equals 0, therefore x equals negative 3. Now don't fall for it. One of the choices is just going to be 7, one of them's just going to be negative 3, one of them's going to be both, and one of them will probably be the empty brackets. Alright, and someone's going to fall for it every time. Make sure you check. And we've said it a billion times this year, when you check, you are checking in the original. Check in the original. So let me go grab that equation. Oh, is x equals radical 30 minus 2x plus 3. And the two numbers I am checking, so I'm going to say let x equal 7. So I'm going to replace every x with a 7. So 7 equals the square root of 30 minus 2 times 7 is 14 plus 3. That's x equals the square root of 16 plus 3. The square root of 16 is 4. 4 plus 3 indeed does equal 7, so I would say that 7 checks. Alright, now I'm going to do the same thing with negative 3. So x equals negative 3. Negative 3 equals the square root of 30. Negative 2 times negative 3 makes a positive 6 plus 3. So I've got negative 3 and the square root of 36 plus 3. The square root of 36, of course, is 6. 6 plus 3 equals negative 3. I would say that's a big fat false. That is not true. So I'm going to reject that answer, and I'm going to say that my only answer is x equals 7. Alright, so I've picked a little uglier one this time. 2 radical x plus 3 equals 3 radical x minus 2. Now, remember, your goal is to get the radical by itself. Is that possible here? I mean, you could take this 2 and divide it over, but then this radical's by itself, but this one isn't. You could take this 3 and divide it over. This radical's by itself then, but this one isn't. It's just not possible in this case, and it's very rare that this happens, but it certainly could happen. So the only thing I can do is really jump to step 2, and that is to square both sides. I really can't do anything else but square both sides. So I'm going to remind myself what it means to square. Okay, that means write it twice and FOIL. But you'll notice you're not actually foiling because I don't have a plus or minus sign, but let me write it down twice anyway. And you'll notice this is just what we did before. You're basically just multiplying the outsides and the insides because there's no foiling, because there's no plus or minus. So outside is going to get me 4. Inside, hopefully you figured out now, any radical times itself is really just the junk under the radical. If you're not buying what I'm saying, think about this. What's radical 5 times radical 5? Well, you might say radical 25, but what does that reduce to? Just the number 5. It works every time. Anytime you take a radical times itself, you're going to get what's under there. If you don't believe me, try radical x times radical x. Multiply the insides, that's x squared, and now the square and the square root cancel, and you just get x. Alright, so those cancel. Outsides, I'm going to get 9. Any radical times itself is just that junk, so quantity x minus 2. I'm going to clean her up. Let me get rid of this for you. So that's 4x plus 12 equals 9x minus 18. I'm going to subtract my 4x over, so that gets me 5x. Add my 18. If I add 18, that's going to get me 30. Therefore, divide by my 5, and you should get x equals 6. Now, we'll go ahead and do a quick check, of course, back in our original. So here's my check. 2 radical. I'm letting x equal 6. 6 plus 3 is 9. Equals 3 radical. 6 minus 2 is 4. And I'll clean that up. This becomes a 3, and 2 times 3 is 6. 4 becomes a 2. 3 times 2 is 6. Therefore, it does check, and my solution was this x equals 6. Alright, our last examples tonight are about fractional exponents. So here are your 2 rules. Isolate the base and exponent, and 2, raise both sides to the reciprocal. So let me remind you what that word reciprocal means. The reciprocal of 2/3 means flip your fraction to 3/2. The reciprocal of negative 1/2 means flip your fraction, so that becomes negative 2/1, which of course is just negative 2. Alright, so here's a fractional exponent equation. So first, I want to isolate this fractional exponent and who it's attached to. And you'll notice I'll just box around. That exponent's only attached to this piece. So the first thing I got to kick to the curb is that number 4. And I'm just going to subtract it from both sides. So I have the quantity x plus 2 to the 3/2 equals 27. Alright, so now I'm at that fractional exponent spot, and the rule is raise both sides to the reciprocal. And just again, that means flip your fraction. So I'm going to raise both sides to the 2/3. Okay, and that, obviously, I get 6/6, which is 1. That's why those cancel when I multiply the tops and bottoms. So I'm going to be left with x plus 2. And on this side, remember, we can do this in our head. Now, certainly you can type this in your calculator, but the root goes on the bottom. It's the cubed root of 27. So what 3 times makes 27? Hopefully you know that's the number 3. And then that's 3 to the second power, which gives me a 9. If I solve here, I'm going to get x equals 7. Now certainly you can check that answer just by plugging it back into the original, and when you plug that back in, hopefully we get 31. Let's try one last one. And hopefully this is a pretty nice one. So again, I just want to stress that that exponent is only attached to the x. Alright, and I think it's so helpful if you just circle it for yourself. Notice it's not on the 3x. If I wanted on the 3x, that 3x would have to be in parentheses. That is very different from 3x to the 1/3, where it's only sitting on the x. So again, I'm just going to start by moving terms over. I'm going to subtract my 6. So I've got 3x to the 1/3 equals 3. Divide both sides by 3. So again, I'm just trying to get this term by itself. So I've got x to the 1/3 equals 1. Now again, this fractional exponent, just raise it to the reciprocal. The reciprocal of 1 over 3 is 3 over 1, or just 3. Again, I'll get 3 over 3, which is 1. So x equals 1 to the 3rd is just 1. And again, we could plug it back into the original to check our work. Well, that does it for us tonight. We've got a big CASEL learning assignment ready to go for you. And we'll see you tomorrow. Have a great night.